Members, welcome to TED Talks. We are still continuing with the biology, and for this session, we want to see the effect of pH on enzymes. We can largely take it there that the effect of pH on enzyme controlled reactions. So, how many pH ranges do we have? We have a pH range that is ranging from 0 to around 6.9, which we would call acidic. We would call it acidic. In other words, there are hydrogen ions present in the solution. Then we have a pH range which is ranging from 6.9 to 7.1. This pH range we can collectively term it as neutral. Then we have a pH range that is stretching from 7.2 to 14, which we would call alkaline. In alkaline media, we expect that the solution is full of hydroxyl ions. So, what is the effect of pH on enzymes? We would say that specific enzymes work in specific pH ranges. Enzymes do not work on at a specific pH, but rather in a specific pH ranges. If placed in a solution of a different pH range, if placed, catalysis of that enzyme stops. So we want to see this effect. Why does catalysis of that enzyme stop when placed in a pH range that is not specific to it? Why? Because enzymes are proteins in nature. Presence or absence of a certain ion, can even take an example, hydrogen ions or hydroxyl ions, denatures the structure, the protein. When a protein is denatured, as we saw earlier, the three-dimensional structure that is functional is lost. Meaning the amino acids it is supposed to expose to in a certain level, which we are going to call an active site in our subsequent discussions, is also lost. So when such is lost, it would mean it can no longer catalyze. So let's look at some examples of enzymes we know and their pH ranges. Examples of enzymes and their pH ranges. If you took an example here, example 1, salivary amylase. Salivary amylase in the mouth acts better in a pH range of 6 to 11. So it slightly works in almost slightly acidic medium. It can continue to function, and also alkaline medium. But largely to say, this is more alkaline than acidic. So if we have sodium hydroxide and we remove our saliva, intubate food substances with the sodium hydroxide and hydrochloric acid, we expect that catalysis and hydrolysis is going to take place where sodium hydroxide has been placed in our subsequent experiments. Then too, pepsin acts better in a pH range of 1 to 5. Meaning if we got pepsin and intubated it with the protease, the proteins in presence of sodium hydroxide, catalysis will not take place because sodium hydroxide is alkaline. And now we can know pepsin is in the stomach and the stomach pH is acidic. Acids are sour and corrosive to the skin. We know why we get ulcers. We shall reach there. But if you have ever vomited, you can feel how sour the vomit is because the acidic medium in the stomach makes it sour. 3. We can also talk about pancreatic enzymes. Pancreatic enzymes. What are those enzymes? Lipase, amylase, and trypsin. These work best in slightly alkaline media. So meaning when chyme leaves the stomach and goes into the duodenum, these ones are the duodenum. So it means when chyme leaves the stomach to the duodenum, the pH has to change. The pH of chyme has to change to alkaline medium, such that these 3 enzymes can act. So you can see that enzymatic reactions can continue provided a pH range is maintained. When the pH range goes out of hand, presence or absence of a certain ion, major hydrogen ions or hydroxyl ions, denatures the enzyme, and so catalysis of that enzyme stops. We find when substrates have not been turned into products. So in our subsequent, let's come back and discuss substrate concentration effect on enzyme activity.